3.2 Understanding Relations and Functions. So as we go through this, first of all, a relation is just, as it states here, a set of ordered pairs, x and y. Now a relation can be a function, but it doesn't have to be. A function must always be a relation. Okay, so remember that. If it says something is a function, then you know it's a relation. If it's a relation, you have to check if it's a function. Remember the x are your domain, the y's are your range. And there are different ways to represent these. So one is like it says with ordered pairs. So as you see right here, another way to represent it is with a table. Another way to represent it is with a graph. You can also represent it with what is called mapping. And mapping is basically just ordered pairs, but it has x in one, y's in the other. Now the thing about mapping is they don't always have to go together. If you look here, they go in numeric order, and I'll talk about that as we do some problems here. How do you recognize whether or not something is a function? Just remember, x's cannot repeat. X's cannot repeat. Okay, keep that in mind. Another way to do it, that's something maybe you're more familiar with, is what is known as the vertical line test that you see right here. And we're going to do that with some problems here too. So we're going to go to the evaluate section, and we're going to skip down here. And the first thing we're going to do is problem 1. It says express each relation in different forms here. So the first way it says is to do it using a table. So we have our relation given to us right here. In a table, we just list all of our x values. So our x's here are 5, 6, and 7. Now, you can list 6 again here in a table, and we're going to show the difference here in a table and mapping here in just a second. So right here, those are all our x's, our domain values. Okay, our y's are 10, 20, 23, and 35. So in a table, you want to keep them corresponding to each other. In other words, 5 has to go with 10, 6 with 20, 6 with 23, 7 with 35. Now, I told you earlier, x's cannot repeat. So immediately, because I have 2 x's here, 2 x's here, I know this is not a function. I know it's not a function. And we'll look again here in just a second how we show that. Next it says by graphing. So we're just going to plot each point. So we have 5 and then 10. We have 6 and 20. We have 6 and 23, which is a little bit higher. And then we have 7 and 35. Okay, so earlier we said something about a vertical line test. When you draw a vertical line, a line straight up and down, it cannot hit 2 points at the same time. So right here it does. Why does it do that? Because the x's repeat here. That's why this is not a function. Okay, the last way to do this is what's called mapping. Now, in mapping, you do age, which is your x's here, which are labeled down here. So labeling graphs, labeling maps, all those things are very important. In a table and in points, you just have values for x and y. The difference in mapping and a table is in mapping, you only list the values one time. So 5, 6, 7. The y's are 10, 20, 23, and 35. And then what you do is you draw lines connecting them. So 5 goes to 10, 6 goes to 20 and 23. Because this x goes to 2 y's, it is not a function. And then 7 goes to 35. Alright, let's do problem number 4. So state the domain and range of each relation. So the domain here, use a big D for domain. The domain is our x value. So here it's 57, 68, 93, 99. our range, we use a big R, is 9 and 2. I'm going to put them in, numeric order, so 2, 9. So just for sake of argument, let's look at this one real quick. Is this one a function? And the answer is yes, because each x only has one y. Each x only has one y. It doesn't matter if the y repeats. This 2 goes to two different values. That 9 goes to two different values. That's okay. It's just the x's we look at. So remember this, okay? X's can only be listed one time. They can only be correspond to a single y value. All right, let's go to problem number 9. So 9's on this page here. A person can burn about 6 calories per minute bicycling. Let x represent the number of minutes bicycled and let y represent the number of calories burned. Create a mapping diagram to show the number of calories burned by bicycling for the given minutes. Okay, so what do we have? We have 60 minutes, we have 120 minutes, we have 180 minutes, and we have 240 minutes. Now, as far as the number of calories burned, it's 6 per minute. So here's where you want to get your calculator. So what are you going to do? Since it's 6 per minute, and something I want to emphasize again, I said this earlier in our lesson somewhere, but anytime you see that word per, think about slope. Think about slope, okay? Per and slope, and we'll talk about that more. But I do 60 times 6, so that's 360 calories for 6 minutes. Then I do 6 times 120, and that's 720 calories per minute, or total. 180 times 6 would be 1,080. And then I do 240 times 6, and that's 1,440 calories. Okay, let's go to problem number 11. I'll scroll down a little bit here. An electrician charges a base fee of $75 plus $50 for each hour. That's like $50 per hour. So again, that's kind of like our slope, and again, we'll talk about this more. The minimum the electrician charges is $175. Create a table that shows the amount the electrician charges for 1, 2, 3, and 4 hours of work. Okay, so what does the electrician charge for 1 hour? Well, if we used this original sentence, we might think it's 75 plus 50 times 1. That would be the formula, and that would be 125. The problem is, in this problem, it says the minimum the electrician charges is 175. So even though we get that using this formula, he still charges 175, no matter what. Okay? So what I have to do is I have to try this formula with each hour, see how much I get. So 75 plus 50 times 2, well, that would be 175. So 175. Then what's going to happen? Well, because it's $50 per hour, I know it's going to go up 50 each time. Let's just try it here. 75 plus 50 times 3. If you do that on your calculator, you get 225. Well, guess what? That is $50 more than this 175. So then that tells me for the 4 hours is going to be 275. I don't even have to do the formula because I know it's got to add $50 more. Okay, let's skip ahead to problem number 17. Oops, page. Okay, it says use the vertical line test to determine whether or not the given relation is a function. Okay, so vertical line, you just draw a vertical line, and I immediately see right here it hits 2 points when I draw that vertical line. Because it hits more than 1 point, it is not a function. Okay, let's try another one. Let's try problem number 19. Now, when I draw a vertical line here, it may look like it hits more than 1 point, but actually it doesn't. Every time I draw a vertical line, I'm only hitting 1 point each time. So this one is a function. Okay, that one is a function. Another way to do this is take a piece of paper and hold it vertically and slide it and see if you hit more than 1 point on the function. Remember again, in the previous lesson we talked about this is called a discrete function, individual points. This is a continuous function, all connected together. All right, let's go to problem number 25 now. It says, explain the error. A student was given a graph and asked to use the vertical line test to determine if the relation was a function or not. The student said that the relation failed the vertical line test. Well, here's why they said it failed. Because it hit 2 points. The problem is they didn't draw a vertical line. They drew a horizontal line. Okay, so if we actually drew a vertical line, we're only going to hit it at 1 point every time. So in actuality, this really is a function. So make sure you know the difference in a horizontal and vertical line.